All right, one more to go here today. And we're going to talk about logarithmic differentiation, which is kind of a cool way to find derivatives of complicated functions and really not using anything new. So students will be able to find derivatives with x in both the base and the exponent by using logarithmic differentiation. Vocab, chain rule, product rule, logarithms, logarithmic differentiation. That's really the only new one that we have here. All right, so first a little bit of review. My guess is you could whip these out pretty quick. So if you want to try them, pause the video. I'll see you in a second. All right, first one, natural log x squared, 1 over x squared times 2x. Cancel out an x, that's 2 over x. E to the 2x, leave it alone. E to the 2x multiplied by the derivative of the baby function, which is 2. So I'd write that as 2e to the 2x. Derivative of x squared, 2x. Right, not too bad. The reason I have that here is because I want to distinguish between these two. Derivative of 2 to the x is going to be 2 to the x, leave it alone, times natural log of 2. There you go. Next one, log base 3 of 1 over x. So that's going to be 1 over x times ln of 3. Right, that's the derivative of the outside function. And then times the derivative of 1 over x, that's x to the negative 1. Oop, just negative 1. So that's going to be negative 1. X to the negative 2. Let's see if we can put this all together here. So we have, let's see, negative 1 up top, divided by that x squared will go on the bottom, ln of 3, and then multiplied by the reciprocal, this 1 over x, that puts an x on the top. One of those x's can cancel, so it looks like negative 1 over x ln 3. Cool. All right, derivative of x to the root 2, x to the root 2 minus 1. Right? Can't really combine those, so I'll just leave it like that. Ooh, did I catch anybody on this one? Who said 4 pi cubed? Pi to the 4th is a constant, and derivative of any constant is 0. Hopefully I got somebody on that one. I was trying to catch you guys. All right, so now let's talk about logarithmic differentiation. So this is a technique that you use when you have an x in the base and in the x in the exponent. So x in base and exponent. And it's really not that hard. All you do is you say, okay, y equals x to the x. And you say, well, I don't like that x in the exponent. How do I get it down? Well, logs make that really easy. So let's take the natural log of both sides. Natural log of y is equal to natural log of x to the x power. Now I can bring that x to the front. So I have natural log y, not x, y, equal to x ln x. Now I'm going to take the derivative of both sides. So the left side, I have 1 over y times y prime, right? Because derivative of natural log is 1 over the value inside here. We've got a chain because we don't know what y is. And that is equal to, we have to use product rule here, right? So it would be 1 times ln x plus x times derivative of natural log is 1 over x. So we have 1 over y prime, equal to natural log x plus 1. Now, we don't like having y's, but if we multiply by y here, we have y prime equal to y times ln x plus 1. But we know what y is. Y is x to the x. So that is x to the x power times ln x plus 1. And that's our derivative. So big things here that are different. You got to take the log of both sides. Then we move the x to the front, derive. And then when we move the y over, we got to resub in the y for what it's equal to. Let's try it with this one over here. If you want to try it first, go ahead. Let's try this together. So if we take the derivative here, or not the derivative yet, but we're going to set y equal to x to the sine x. Now we'll take the natural log of both sides. So we have ln y equal to sine x ln of x. Hopefully that was okay, right? I just took the natural log and then moved the exponent to the front. Now we take the derivative of both sides. 1 over y prime. That is always what you'll have on the left, equal to, let's take the derivative of sine first. So we have cosine x ln x, and then it'll be plus sine x times 1 over x. Now we multiply by y. So y prime is y times cosine x ln x plus sine x, let's just do over x. Now replace the y with x to the sine x. So y prime is x to the sine x times cosine x ln x plus sine x over x. Nice. We just did that one. I forgot that I had it on both screens. I wanted more room, but that's okay. We already did it. So Now, don't forget about the log properties, because if you have something like this, you once again could start going into some really complicated chain and product rule stuff. But remember, this is a product. I can split a log of a product into two sums of logs. So I have log x plus log of 10 to the sine x. Now, this is log base 10. So I'm asking, what do I have to raise 10 to get 10 to the sine x? Well, that's sine x. So this is log x plus sine x, right? Because this is just the inverse function of 10 to the x is log base 10. So it just cancels each other out. So you have derivative. So that is 1 over x log 10 plus cosine x. And we actually take the derivative. So don't forget, Euler will tell you, be smart. Nice. Use your log properties. And that is all I have for you guys. Thank you for your attention. I love you guys. That's why I'm here. Have an excellent day.